Hi, I'm Dr. Lauren Ayton from the University of Melbourne, and I was the 2019 AIPS Tall Poppy of the Year for Victoria. And it's really a huge pleasure and an honour to be able to talk to you a little bit about my research that I do at the University of Melbourne and the Centre for Eye Research Australia. So I work in the fields of optometry and ophthalmology, so basically looking at eyes. And I'm very interested in retinal disease and how that leads to low vision, and then how we can actually help people that have lost their sight from these diseases. So the retina is the film at the back of the eye. It's kind of similar to the film in a camera, and it's made up of very complex layers of cells. And unfortunately, there's quite a few things that can go wrong with the retina. And I'm particularly interested in diseases which are genetic and inherited. And unfortunately, these are often diagnosed in children or young adults. And so what my group are really trying to do is learn more about these diseases, why they cause vision loss and blindness, and what we can do to help people that have become blind from retinal disease. So my group works between the departments of optometry and vision sciences and ophthalmology, and we work with a lot of multidisciplinary collaborators. So we work with engineers and material scientists and physiotherapists, and that really makes my job incredibly exciting. Every day is different, and we're always getting to learn new things. So I wanted to share a couple of images to show you what our group does. So this is a bit of a summary of some of the areas of research that we work in. And so in terms of vision restoration, there's quite a few ways that are being developed that you can help someone who's lost their sight from retinal disease. And so one of these is the Bionic Eye, which I'll talk about a little bit more in a minute. Gene therapy, where you can actually try and replace faulty genes that are causing these eye diseases. We're very interested in low vision aids, and in particular in some of the new technologies which are doing things like taking pictures and changing them to audio output or even tactile output, so that people can get some input about their environment. And of course, we're very interested in the retinal diseases themselves and learning more about what happens to the eye as these diseases progress. So one of the probably most well-known vision restoration devices is the Bionic Eye. And even though when you hear those words, you probably think of Steve Austin and the Bionic Man, unfortunately, it's not quite at that level of technology yet. What the devices are electrodes which are implanted either into the eye or further back in the visual pathway. So they can be implanted in the nerves that go from the eye to the brain, or even in the brain themselves. And what we do is take a picture of the scene around a person, we change that picture into electrical signals, and then we use the electrodes implanted along the visual pathway to give back some sight to the person. So I've been incredibly privileged to be involved with the Bionic Vision Australia project, which has been running for a number of years in Melbourne, and also worked in the US on another Bionic Eye device for a number of years as well. The exciting thing with these devices is they're developed for people that have no real remaining vision. And the best way to think about this is if you close your eyes, that's the baseline level of vision that somebody has who receives one of these devices. And the implants then allow them to see large objects, things like a doorway or where the lights are in a room. And that can be really rewarding for someone who hasn't had vision for a while. In addition to the Bionic Eye, I'm working in other techniques such as gene therapy. And so gene therapy is when you use a virus to take a correct copy of a gene into the eye, in our case, to restore the function of cells that aren't working properly anymore. So what my group are really interested in is all of these different techniques and interventions. We want to show that they can work effectively. So we're very interested in outcome measures, being able to show that the devices improve someone's ability to navigate around obstacles, for example, or see objects. So that's really what our aim is. One of the questions that I've been given is, what is one of the weirdest things I've done for my research? And this picture I quite like because it really sums it up. We obviously, most of my team have got normal vision, and so we need to learn what people who have low vision actually see. And so this setup here allows us to do that. So we can actually use eye trackers and use simulated algorithms to actually change the vision that we have into something that might be experienced by someone with a retinal disease. So one of the weirdest things I've done from my research is wear a get up like this and walk around the streets of Melbourne and Canberra and basically try and experience what it is actually like to have low vision. That's one of the most important things with our research, is making sure that we learn what it's like to have natural low vision, and also what it's like to have that vision changed by some of these interventions. The other thing that I'm incredibly blessed with is the ability to work with such amazing people. And so I just wanted to share some images to sort of give you an idea of how large research really is. So these are some of the collaborators that I work with across numerous institutions, the University of Melbourne, the Centre for Eye Research Australia, and the Bionic Institute in particular. And really, all the work that I do couldn't happen without these large teams. So it's an incredibly blessed job to have. So I guess in closing, I really would encourage everyone that's watching to consider research as a career. I've been incredibly blessed in my job. I've been able to experience amazing opportunities both here and overseas. But I think really what it comes back to for me is this overwhelming need to actually help people that have lost their sight. So the reason I got into optometry and ophthalmology research is that my older brother was actually blind, and so I always wanted to be able to help him with that. And so that's really why I keep going to work every day, and really thank the AIPS for their support, and hope that my story might have made a difference for you today. Thank you.